How engineers are building the longest tunnel beneath the sea. There's a tunnel being built so deep beneath the sea that it could connect two countries faster than you could finish a cup of coffee. A project so massive that it challenges everything we thought was possible underwater. Some people say it is far too dangerous to build beneath the sea, while others believe it represents Europe's boldest dream. How can engineers dig an 18-kilometer passage under the seabed without flooding the structure, collapsing the soil, or disrupting marine life? Today, we are taking a close look at how the world's longest underwater road and rail tunnel is being built. The Feyar Belt Tunnel, Europe's giant project. Across Europe, countless infrastructure projects receive headlines, but one of the continent's most ambitious undertakings has been progressing quietly in the Baltic Sea. This is the Fehmarn Belt Tunnel, a colossal link that will connect the Danish island of Lolland to Germany's Fehmarn Island. It may not yet be complete, but once finished, it will completely redefine how people and goods move between Scandinavia and Central Europe. This structure is not just a tunnel. It is a missing link in Europe's larger transport vision that has been decades in the making. At the heart of this plan lies the Trans-European Transport Network, known as TEN-T. This initiative is designed to connect all regions of the European Union through a seamless web of roads, railways, ports, and airports. The Fehmarn Belt Tunnel is a vital part of the Scandinavian Mediterranean corridor within that network, closing one of the last major gaps in Northern European connectivity. When I first learned about this project, I was genuinely surprised that something of this magnitude was not making more headlines. This is currently one of Europe's largest construction sites, yet many people have never even heard of it. What is happening here is quietly reshaping the entire way Europe will move and trade in the years to come. The problem it's solving. For decades, transportation across Northern Europe has struggled with bottlenecks that slowed both passengers and freight. Trains traveling between Germany and Denmark often shared single-track sections where they were forced to wait for oncoming traffic. Meanwhile, cargo routes linking Scandinavia to Central Europe were hindered by delays, ferry crossings, and capacity limits. The Fehmarn Belt region has long been one of those slow points, where ferries take nearly an hour to cover a short distance that could be crossed much faster if a fixed link existed. That is exactly why this tunnel matters so much. It forms a key part of the Scandinavian Mediterranean corridor, one of the 9 core routes of the TEN-T network. Once complete, travel times will be dramatically reduced. The same trip that takes roughly 1 hour by ferry will soon take only 10 minutes by car and about 7 minutes by train. This will not only improve personal travel, but also give freight operators a faster, more reliable connection between the Nordic countries and the rest of Europe. What makes it even more significant is sustainability. By shifting more freight from road to rail and relying on electric trains, the project supports Europe's broader goal of lowering carbon emissions. As someone who studies infrastructure systems, I can say this tunnel is not just a shortcut. It is a key investment in Europe's economic and environmental future. How do you build a tunnel under the sea? Constructing a tunnel under open water is one of the most challenging engineering tasks imaginable. Instead of boring through rock like a traditional tunnel, the Fehmarn Belt project uses the immersed tunnel method. Enormous concrete elements are built on land, each one the length of 2 football fields, and then they are floated out to sea and lowered into a carefully prepared trench on the seabed. That trench is about 18 kilometers long and has to be excavated with extraordinary precision. Specialized dredging ships equipped with GPS-guided systems remove the sediment from the seafloor with centimeter accuracy. Survey points on both shores continuously guide operators to maintain depth and alignment. Despite its massive scale, the excavation must remain extremely clean. Before each tunnel section is placed, the trench is cleared of any sediment using suction systems that work much like a giant underwater vacuum cleaner. The Baltic Sea might appear calm, but working beneath it requires perfect coordination between technology and human expertise. Because the region has very stiff soils and limited tidal movement, the trench stays stable, yet even small shifts can have serious effects. The level of accuracy required here is astonishing. The process must ensure that each tunnel element fits into position precisely, creating a seamless underwater passage. The precision and patience behind this process are what make this engineering achievement so remarkable. One small error could set back years of work, and that reality alone shows how carefully every step must be executed. A factory that builds oceans of concrete. To produce the immense components needed for the Feyar Belt Tunnel, engineers constructed an entirely new manufacturing complex on the Danish coast. This facility, regarded as the largest tunnel factory in the world, operates with 6 production lines dedicated to creating the tunnel elements. Each element measures around 217 meters in length, 42 meters in width, and 9 meters in height. To understand their size, each one weighs as much as 13,000 elephants. The process begins with the assembly of a steel reinforcement cage that forms the skeleton of the concrete structure. The base plate is set first, followed by the side walls, and finally the top slab. The element is then moved forward through various stages, similar to an assembly line, where each of the 9 segments that make up a full element is cast one at a time. Casting a single segment can take more than 30 hours, and the temperature, humidity, and curing time must all be carefully controlled to achieve the required strength. These controlled indoor conditions ensure that no external factors such as wind, rain, or snow interfere with the quality of the structure. The result is a series of precisely made tunnel sections ready to withstand the pressures of life under the sea. Once the casting is complete, each element moves to the outfitting area where watertight bulkheads, technical systems, and safety features are installed. Adjacent to the factory sits a newly built harbor, now Denmark's 3rd largest, constructed solely to handle the transport of these massive elements into the Baltic Sea. As I see it, this entire operation feels like the heartbeat of modern European engineering. Standing at the site, surrounded by towering concrete forms and machinery, one can sense that this is not just a construction project, but a glimpse of how future infrastructure will be built. The moment of truth beneath the Baltic. When each massive tunnel element is finally ready, the process of moving it from land to the sea becomes one of the most complex stages of the entire project. The completed concrete section is carefully guided out of the production basin into open water with the help of large immersion pontoons. These pontoons are flat floating platforms that rely on air-filled chambers to remain buoyant. Once connected to both ends of the tunnel element, they hold the structure just above the surface, balanced and perfectly aligned for transport. The operation requires calm and predictable sea conditions known as weather windows. Engineers study forecasts closely and only proceed when the wind and waves are stable enough to ensure safe movement. When the timing is right, tugboats take over to guide the pontoons, carrying the tunnel element from the factory harbor to the immersion zone in the Feyar Belt. Every meter of this journey is monitored in real time with high-precision GPS systems to prevent even the slightest deviation. Once the element arrives at its location, it is lowered gradually using multiple steel wires that are synchronized to maintain level descent. The process has been compared to threading a needle 40 meters beneath the surface of the sea. Every motion must be smooth and perfectly timed to prevent twisting or misalignment. On the seabed, the prepared trench awaits, ready to receive the new piece of the tunnel. Engineers then guide it into place so that it connects seamlessly with previously installed section. After positioning, the space on either side of the tunnel element is filled with sand and gravel to stabilize it. A protective stone layer is then added on top to safeguard it from anchors or debris. This entire operation takes precision, timing, and nerve. I cannot imagine the pressure these engineers must feel during these moments with literally millions of euros hanging on steel cables as they lower each segment into the depths of the Baltic. An armada for a tunnel. Behind this enormous construction effort is a full fleet of vessels, working in coordination like a floating factory. Tugboats pull the finished elements across the water, while dredgers handle the excavation and cleaning of the seabed. Immersion pontoons carry and lower the tunnel pieces. Multicats assist in anchor handling, and cruise ships transport workers and equipment to the site each day. Every vessel performs a specific role that keeps the operation running safely and efficiently. Safety is treated as a science in itself. Every winch, wire, and anchor system has a backup. Before any immersion takes place, simulated tests are carried out both virtually and physically to check that all systems respond exactly as required. The project team monitors weather patterns around the clock, since even small waves or unexpected currents could disrupt the lowering process. Each captain, diver, and engineer involved in the immersion operation has undergone extensive simulation training before stepping onto a real vessel. The goal is to ensure that everyone knows every movement, every procedure, and every emergency step by heart. It feels almost like a ballet of heavy machinery across the sea, each vessel moving in rhythm with the others, every task executed with precision, and every possible mistake accounted for before it can happen. The people who dream beneath the sea. Large-scale projects often seem mechanical, but behind the Feymarn Belt Tunnel are real people whose dedication keeps the work moving. One of them is Marcus, a construction area manager who oversees part of the tunnel outfitting process. He shared that this project holds a special meaning for him personally. He grew up in Germany, studied in Hamburg, and now lives in Denmark, the very two countries that this tunnel will soon unite. For him, it is more than just work. It is a bridge connecting his past and his present. Listening to people like Marcus reminds me that engineering is not only about numbers, materials, or machines. It is also about pride, connection, and the shared belief that human effort can overcome distance. The tunnel team is made up of thousands of professionals from several European countries, all contributing their expertise to create one single continuous structure beneath the sea. The Feymarn Belt Tunnel is scheduled to open in 2029, and when it does, it will mark a new chapter in European transport. Beyond the concrete and cables, this project represents collaboration on a continental scale. It stands as proof that when people from different nations work together toward a common goal, even the sea itself cannot stand between them. A tunnel that redefines Europe. Once the Feymarn Belt Tunnel is completed, it will reshape the geography of European travel. By linking Germany and Denmark with a direct road and rail route, the project will significantly cut travel time for both passengers and freight. It will also contribute to environmental goals by reducing carbon dioxide emissions, since more goods will be transported by electric trains instead of diesel trucks or ferries. The tunnel will shorten logistics chains between Scandinavia and Central Europe, helping industries move products faster and more efficiently. Tourism is expected to benefit as well, with new opportunities for cultural and economic exchange between the northern and southern regions of Europe. The fixed connection will strengthen trade, create jobs, and provide a major boost to long-term sustainability targets. For generations, ferries have been the only option across this part of the Baltic Sea. That will soon change. The transition from slow crossings to a high-speed link symbolizes a broader transformation in how Europe connects its people. As someone who has spent years studying modern transport systems, I see this tunnel as far more than a shortcut. It is a clear demonstration of what humans can achieve when they choose cooperation over division and vision over limitation. This project is not just building a tunnel, it is building a legacy that future generations will travel through. From an initial sketch on paper to an 18-kilometer underwater connection, the Feymarn Belt Tunnel proves what persistence, precision, and collaboration can accomplish. It stands as a remarkable example of modern engineering and international teamwork. What other hidden engineering achievements would you like to learn about next? Share your ideas in the comments, and remember to subscribe so you do not miss the next story of human innovation beneath and beyond the surface.